Good afternoon. Welcome to PCI's webinar series. Today's presentation is Improving Quality and Cost Control with Model-Based Precast Engineering. This webinar is sponsored by ALLPLAN. My name is Nicole Clow, Marketing Coordinator at PCI, and I will be your moderator for this session. Before I turn the controls over to your presenters for today, I have a few introductory items to note. Earlier today, we sent a reminder email to all registered attendees that included a handout of today's presentation. That handout for this webinar can also be found in the handout section of your webinar pane. If you cannot download the handout, please email PCI Marketing at marketing@pci.org. Please note that all attendee lines are muted. The GoToWebinar toolbox has an area for you to raise your hand. If you raise your hand, you will receive a private chat message from me. If you have a question, please type it into the questions pane where I will be keeping track of them and will read the questions to the presenters during the Q&A period. Also, a pop-up survey will appear after the webinar ends. Today's presentation will be recorded and uploaded to the PCI eLearning Center. Questions related to specific products or publications will be addressed at the end of the presentation. PCI is a registered provider of AIA CES, but today's presentation does not contain content that has been endorsed by AIA. Today's presentation is non-CEU. Our presenters for today are David Lockery, Business Development Manager at ALLPLAN. David has a master's in structural engineering with over 7 years of industry experience. As a practicing engineer in China, his work focused on fiber composites and civil infrastructure, including bridges and power plants, before he transitioned into the AEC software industry upon returning to the United States. As an engineer, he's faced many of the same challenges which confront ALLPLAN's customers each day, and understanding which enhances his ability to help overcome them. Joining David is Anders Levendahl, technical consultant at ALLPLAN. Anders studied at Oregon State University before starting his career at a precast manufacturing facility specializing in prestressed precast concrete bridges and drafting. He also has experience as a CAD manager, supporting civil and structural engineering teams throughout all phases of project delivery. He enjoys keeping up with emerging technology that can create innovative workflow solutions for infrastructure projects, which was a driving factor for joining the ALLPLAN team as a technical consultant. I'll now hand the controls over so we can begin our presentation.
Thank you for that introduction, and good afternoon, everyone. I am David Lockery, Business Development Manager with ALLPLAN, dealing with our precast and infrastructure markets. I have with me Anders Levendahl, our technical consultant for precast. Glad to see some familiar faces back. Nice to see some new folks as well. As our abstract covered for this presentation, we intend to put in front of everyone a workflow for model-based precast engineering, drafting, and detailing that will have the aim of improving quality and cost control in the operations that take place downstream from engineering and detailing. Today, when we deal with a project like the wonderful parking garage graphic I have here, we see folks with a variety of disparate engineering, drafting, visualization, estimation processes. Folks start out in a spreadsheet and maybe in Bluebeam for estimation purposes. They win a fraction of the bids that they put out the door, and then they hand that entire project over to another team who is basically going off of some very rudimentary engineering drawings, perhaps an early stage design from an EOR, to go in and really start from scratch when it comes to detailing. And what that means is that you're almost always starting behind the 8 ball. You have a very labor-intensive process trying to move engineering forward as quickly as possible, to produce shop tickets, to produce bills of materials, the things that are going to drive folks' behavior in a factory, the behavior of your purchasing departments. And when we do these things in CAD, the lack of automation, the lack of quality control really can bite us quite hard. We are finding, talking to folks, that right now good drafters and engineers are hard to find, for precast especially. It requires a very specific skill set, very specific experience. It's hard to cultivate. And with this, it becomes more important than ever to be able to put a little bit more automation and more intelligence behind the tools that these folks are using. So the workflow that we talk about begins very much in estimation, where we have very good templates that drive behavior. We have the ability to use the 2D, 3D templates to very quickly construct estimation models for projects. What changes, though, is that when we get into um, data continuity, let's just say, when we get into the more detailed stages of a project, I've won that project. I then have the ability to utilize that estimation model in a way that I can't really use any of the kind of data that comes out of estimation today. I have the ability to go into that model and make edits and make changes that are going to allow me to use that model as the engineering model ultimately, save myself time, save myself work. Um, on the basis of that, then we're able to use automation like automated reinforcement in our Python parts to really help your folks build more detail into these projects further in advance. And because of this automation, we're also able to manage changes earlier and better. So we're able to do things like say, look, I want reinforcement in a bar list for all of the double T's in a project very early on, knowing that as that changes, I'm going to be able to update it much more easily than I could in CAD. What that allows me to do is something like tell purchasing months in advance what I expect to need for a project with 90% confidence, rather than days in advance when relying on an outsourcer with 90% confidence. This necessarily impacts costs. So from there, then, once we get into the realm of ticket automation, one of the issues that we consistently see folks say is that they spend a significant amount of time, perhaps as much as half of their drafting hours, dealing with bar and dealing with the configuration and quality control for ticketing. That's it. That is half of drafting or modeling hours today. What we are talking about is a ticketing engine that derives its information directly from the model. So that when the model is correct, the tickets are correct, they are consistent. The tickets of identical mark numbers can be assured to be consistent with one another. The software checks these things. We have conflict checking, the generation of bills of materials automatically from the model. It means that essentially when we go to do all the QA/QC for this, we have a single source of truth, and that source of truth is intelligent enough that we can employ the computer to automate a lot of the tasks that we would ordinarily do manually. What that really looks like in practice, I will leave to Anders to show everyone.
Thank you, David. So we're going to get right into this. As you can see here in the background, I have a precast building modeled. I have some exterior wall panels. And if I turn off the double T roof, you can see that I have some slabs, some beams, and some columns here. Some of the walls have already been turned into precast elements, but this front wall is left undone. So that way I can show you how we're going to do that really quick. I also left this beam over here, a little bit easier for you to see. This beam right here, that is modeled, but it's unreinforced like the other ones and needs to be changed to a precast element. In general, in ALLPLAN, you can model pretty much anything. There's a lot of solid modeling tools, as well as some visual scripting options for modeling whatever you want. We can take those generic shapes and turn them into precast elements so that the program recognizes that they're precast, and automate the rest, like the reinforcement, addition of fixtures and lifters, things like that. And you'll see what I mean as we go along here. We're first going to work on the beam that needs to be reinforced and converted over to a precast element. But I need to turn off some of the drawing files to make it a little bit easier to see and work on this beam. So I'm going to turn off foundation, walls, and slabs, and turn off the double T's and hit close. So this menu that I have open now is the project's building structure, where you can control all of the drawing files associated to the project, and it's basically the way that ALLPLAN manages a project, and also allows for multiple people to work on the project simultaneously and within these different drawing files at the same time. So we'll close that. And then I'm also going to change my views. Let's see here. So now I have a plan view, an elevation view, and then my 3D view. But you'll notice throughout this webinar that I'll be mostly working out of these two views, the plan view and an elevation view, and just using the 3D view just to rotate and maybe zoom in to show what's going on a little bit closer. So the next step is to turn this beam into a precast element. And to do this, we're going to use our precast element tool, which will basically allows us to turn any object into a precast element. The reason we need to change this beam 3D object into a precast element is because ALLPLAN and PlanBar have a full set of 3D modeling tools that really allow you to create anything you want, and not everything that you might be modeling will be a precast element. So this way you can just change the objects you need to be precast with really no limitation. So before I activate the tool, I'm going to actually switch active drawings and turn off this other beam drawing file just so we can see this beam 3D object in plan view more easily. And then I can activate our precast element tool. So now that it's activated, with this tool you can select from several different element types: walls, double T, solids, columns, beams, slabs, and then you can also add additional ones if you need to in your configurations. So really you can choose anything that you model to be a precast element. You can specify what factory it's being built out of. You can also add additional attributes. I think you can add up to 50 attributes. Specify how the piece is labeled. And then also any invoicing information if you need to. So after we've activated our tools and configured our tool settings, all we need to do is select our 3D object. And there we go. Easy as that. It's a precast element. The tool has added a mark number and then also added some additional information to the label. If I hit escape to exit, I can hit it again to escape out of the tool. The label just tells us the piece mark number, the overall length, width, height, and then also the estimated weight. So now that we've done that, there's two ways that we could go about adding reinforcement to the view. We can either cut some sections, or because this is a precast element, we can use our edit elements tool, which will basically allow us to create 3 orthogonal views of our precast element automatically. So if I just select this tool and select the precast element, you can see that it generates 3 views over here in this viewport, and then on the viewport to the right we still have our model. So it's just a quick way of generating three views without anything else in the way so that we can add reinforcement, we can add lifters, we can add any plates, inserts. All right, so now that we have our views, we can start reinforcing the beam by going to the reinforcement tab and selecting bar shape tool. We'll first need to pick our bar shape that we want to use. And as you can see, we have a multitude of shapes to choose from. But if you don't see a typical shape that you need, you can always choose freeform. With the freeform option, you can just trace any shape you wish by clicking the points, and ALLPLAN will automatically adhere to the minimum bar radius or minimum bend radius set for each bar diameter when creating these custom bends. But for this beam, I'm just going to choose the stirrup closed or closed stirrup. And because I have this checkbox expand to adapt to edges box checked, my bar is automatically going to adapt to the profile of my beam. It'll give me a few different options depending on the shape of my beam by hovering over the edges of it. But if we don't want the adapting to happen, we can just uncheck the box. But for this, I'm going to first go with this stirrup along the bottom of the beam. The properties of the stirrup look good to me. Number 4, 2-inch cover, hook angle, hook length. Yep, that all looks good to me. So I'm going to hit escape. And then I'll be prompted to choose the placement of the stirrups. So with this, I can click the beginning of the beam and the end of the beam. You can see that it spaces out the stirrup at 8 inches in the properties. If we want, we could change that here. Just say 4 inches. You can see the total number of stirrups right above. I'm going to keep it at 8. I'm going to change the clear cover to 2. And change how the edge offset is. So I want my bar spacing to start from the first point of the bar placement and continue the spacing from there. And we are good. So I am going to hit escape and hit escape again. And this will bring me back to the bar shape tool so I can continue placing bars. I want to place another stirrup that goes through the top of the beam, so I can hover over the edge of the beam to get it to automatically adapt to those edges. I can left click, and once again, the settings look good to me. Just go with number 4 again. And then we're back into this linear placement tool. I can do the same thing again that we did before. Select the beginning, select the end, and then I'm going to adjust the clear cover because I don't want those bars to be sitting right on top of each other. And there you go. You can see that they're sitting right next to each other, just like that. All right. And actually, I meant to uncheck the same clear cover because I don't want it to change from bottom. I want this bottom clear. You can always click in the image as well. I want that one to be 2 and the clear from the start to be 2.5. So that looks good to me now. I can hit escape and escape. Now that we have our stirrups in, we are ready to place some longitudinal bars. We're not going to go too crazy reinforcing this thing, but I want to give you an idea how quickly this can be done. So we're already in our bar shape tool. We can just go back into our bar shape selector. I'm going to select a straight bar. You can see the properties have changed a little bit. And let's do all the same concrete cover. Let's do 2.5. And number 3 bar sounds good to me. And now I can hover over the edge of my beam and it automatically detects where it should go. So using our views to our advantage, I can choose the longitudinal edge of this beam so that the program expands to the edge and gets the length automatically. Then I can place it where I want. So that looks good to me. And then I can hit escape. Change my placement to be a linear placement. Wants me to select my view, so I can select my view. And then I can choose where I want this straight bar to be. I want it in the corner, so I'm just going to select in the corner. And now that I've done my single placement, I don't necessarily have to use my reinforcement tools to continue to reinforce this beam. I can actually exit out of those tools, and then I can use my normal CAD operations like copy, move, mirror, rotate, and copy this longitudinal straight bar around the beam. So I'm going to do mirror and copy.
So Anders has alluded to this a bit, but one of the concerns and one of the challenges really that we often see folks in this industry bring out is the challenge of getting a system like this or like any other implemented. And we're not just talking about the specific platform, but any real fundamental change to processes. People often see value in new IT solutions, new engineering solutions, new operations platforms, but actually bringing them to fruition is often a challenge because they're not always something that's well attuned to the skill sets that are prevalent in the industry. And for us, that means dealing with folks who have been in this industry for a very long time and who know precast intimately, but have spent their whole lives working primarily in CAD. And as everyone's probably starting to get a feel for by now, we are really addressing that CAD to quote-unquote BIM transition, that 3D transition, by turning it back into a set of work that everyone knows well. Almost everything Anders is doing here is still conducted in CAD. We're just using it to a different end and with more automation and behind the scenes.
So even though we have all these great tools built in for automating your reinforcement and placing it, and we could also draw in any freeform reinforcement. Sometimes it's just faster and easier to use the good old regular modeling tools or CAD operations to get our precast elements fully reinforced. I'd also like to point out that while I was laying out those bars, you may have noticed how changes were happening over in this view automatically of the beam that we're working on, and you can see when I hover over the bars that the ones in our views light up because everything stays associative. Okay, now we're gonna add a fixture to show how that works. Just to explain what a fixture is, a fixture can be any insert, a plate, a lifter, or really anything that's embedded into the concrete. You can create them in ALLPLAN, and save them to your library for you to use at any point or any of your coworkers. So we'll activate the fixture tool. Select the fixture that we want to add. In this case, it's the SPG 503 plate. Click OK. Change the rotation. And then we're going to place the plate here. See, it pops up at the bottom of my beam. So if I want it to go all the way to the top, change the elevation and click cancel. We don't need to label it. And then it's prompted me to place another one. We don't need to. We can exit out of that. But if you want to add any custom embeds, you'll need to create them in here. But most large vendors supply IOC files of their fixtures, and those can be imported and used just like what I just did there with that plate. And you can have the option to keep inputting inserts, but I just did the one and closed out. So now if I rotate my model so you can more easily see it, change my views just to the one viewport. Zoom in on my beam and my situation that I have going on here. And rotate. See my plate here with my reinforcement. And I've got it placed right there on the ledge. That way you can place your slab on top of here and just have a plate at the bottom and weld right to this embed. That's a great thing about 3D modeling. You can easily see if there's going to be a clash. In this case, we might have a clash between maybe some of the studs and the reinforcement. It might be a little too close, but that's truly the power of a BIM model. You can go into the model, see where exactly you're going to have issues before the erectors or the guys in the plant get to it. That way you can fix it ahead of time and really save the project time and money with these issues. So now that we've placed our fixtures, we're going to go ahead and create a shot drawing out of this. It's very easy. Once you have your template set up in your catalog, all you have to do is click on the beam. So let's take a look at how that's done. So I'm going to navigate to this element plan button here. Select that. Zoom out just so we can see our beam. Get out of navigation mode. Now I just have to select my beam. And then after I select my beam, I just select the layout that I want to use or my drawing template. And then I can click OK. And voila. And just like that, you have a precast shop drawing of a beam. I'm going to close this. Make this shop drawing a little bit bigger and easier to see. So you can see that I just had to select the precast element, select the layout template that I wanted to use, and if you blinked, you missed it, and my drawing was created. You might be able to see that the beam is fully dimensioned. The embeds are dimensioned here, and this is how it looks. It's completely customizable, so you can set it up for your company standards. Right now I have my embed labeled as A. This attribute is then automatically pulled into my table at the bottom. You can see it here, my bill of materials right here. The table shows that the label shows the label with the quantity and the piece number, the SPG 503 plate that we placed in earlier. So this will pull in everything that's been modeled and indicate exactly what's in the precast element. You can see the weight, the volume. Again, you can set up these tables and schedules to show any information that you want or the attributes that you've assigned to your precast elements. So this first page is just for my formwork. For this particular beam, I have 2 pages, 2 drawings, one for formwork, one for reinforcing. If I go over to the reinforcing page, you can see that the reinforcing is really nice because not only do I have a plan showing the reinforcement, but right here I have a bar list coming in automatically. Because of the way that the beam is modeled in the stirrups, the program automatically detected that the stirrup shape used for the bottom of the beam and the middle portion of the beam were the same shape. So I actually combined those 2 marks into one in this list of reinforcement here. So you can see there's 116 pieces. So that's an awesome time saver. So again, when you've gone through and modeled everything, the program really takes over and automates all the tedious work for you, generating shop tickets for you, dimensions, creating schedules, and placing all the information you need right here on the shop ticket. And if you ever need to make changes to the model, you can do it right here from the shop ticket because the drawings and the model are linked together. So I'll show you moving the plate that we or the fixture that we've added earlier. So I can just select the plate here. Select the plate. I can easily move it. You'll see that the dimensions update for the plate. If we want to make a copy of the plate, we can do that too. The dimension string automatically updates, and the quantity is updated as well. So again, everything is linked, and when you update the model, the shop drawing updates, and if you make a change in the drawing, the model updates as well as the quantities. So it's an incredibly nice thing. Having a fully linked model not only saves you time, but it also reduces the amount of errors. You don't have to go and switch back and forth between models and drawings in different sections. You can make the changes once, and all the updates happen automatically for you. All right, so now that we have our beam fully modeled, reinforced, we added fixtures, and created a shop drawing for it, we can now move towards the front wall that hasn't been reinforced and turned into a precast element yet. So let's move to that. Change my views. Go back to the 3D model. And then turn back on some of the drawings that I turned off earlier. Turn some of these off to reference mode. Let's see here. that's all we need. All right, so we can see this front-facing wall here. All right, so let's just go ahead and get started. We'll first go to our precast wall tool, activate our design eye wall up here in the ribbon, which will give you a bunch of options within all of these different tabs. But when using this tool, we'll start from this leftmost tab and we'll work our way to the left. So in this first tab, we'll specify the factory that we're using, the element type. So in this case, it's going to be a concrete wall, but we can do double walls, brick walls, sandwich walls, thermal walls. We could add a facing layer, and then also we could change the type of material or type of concrete that we're using. There's a few other options in here. You might be wondering, do I have to set this every time I use this tool? And the answer is no. You can set it once. You can create a favorite down here, and then load it back in the next time that you use the tool. But by default, when you use a tool in ALLPLAN, this is for all the tools in ALLPLAN. Once you use the tool and you go back to the tool later on, the program will remember the last options that you used. So, but in this case, I'm just going to go through the different options here, the different attributes, and just make sure that everything is to my liking. One thing that I think we're going to do is change the surface for the visible side of the wall to steel form, and the invisible side to acid etch. And then I think we're good there. So, and you'll see why I changed those later on when we go to create the shop ticket. So, but now I can go and select that front facing wall, select it. That message is A-OK. We can deal with that later. So now the wall is a precast element. We can change, you can see that it placed this triangle, which is representing the visible side of the wall, and we can just flip the sides, just popping up that same message again. And there we go. So it's on the side that we want it to be on. So currently we have one giant precast wall. It's 855,000 pounds and almost 215 feet long. So we're going to take care of that in a moment and start panelizing this wall and making it into more manageable pieces. So if I move to this next tab in the tool, the connections tab, this is where I can select two intersections of a wall to create a connection between the two. So I can select these two corners. And I can specify the joint that I want. All right. Now I go to the other corner. Do the same thing and select the two walls, the two corners. Change the direction of the joint. It's just another way of ALLPLAN automating a detail for you. have connections between our walls. We can hit escape. So now we have our walls with plate connections between the two. Automatically get placed based on your parameters that you set. So now if we want to go back into the properties of this wall, go back into Precast element design mode. Or sorry, we can relaunch the tool and then we can begin placing any mandatory joints, so joints that we know need to be in certain locations. In this case, I want to place joints to be centered in between these windows. So I will do that really quick.
So while Anders works in the background for a minute, I'll chime in again. I think at this point everyone's seen some of the value that the automation here is bringing to the table. Automating allocation of marks and their reorganization as objects change. Automated tools for detailing bar, for creating bar lists, for creating full BOM, and ultimately then automation for tickets. And drafting automation is great. It allows me to hire the appropriate number of people, pay them well because they're individually more productive. It allows me to put out higher quality tickets. There are a number of things that I can do when I have drafting automation that are just unreachable otherwise. But drafting is a very small fraction of the overall spend that we're talking about here for a typical precast project. And there are a lot more implications to a workflow like this. Right now we push out tickets, we push out a complete BOM, we push out a complete bar list at the end because we have to do it that way. Really, these things are so complicated and so time consuming to create in a 2D CAD environment that I can only ever create them once. I can't possibly do it early on in the process or midway through, or kind of have something that evolves as the project evolves. With this workflow, though, that's not necessary anymore. I can have this information early on because it's arising naturally as a result of doing the project this way. It's almost a byproduct. I can deliver preliminary tickets at the push of a button. I can deliver a preliminary BOM. I can spit out bar lists for certain elements. And that really is the biggest benefit to a workflow like this for the companies that we've had implemented. It is the visibility and flexibility that's involved. We get away from just-in-time processes and the vulnerability that they give us to any kind of disruption. We get away from last-second ordering of materials. We get away from last-second delivery of tickets. We get away from last-second changes. We get away from the last-second production crunch that comes up because I didn't really have all of my project details for 3 or 4 concurrent projects nailed down until weeks or even days before I was supposed to start production. The drafting automation is great, but it affects 5 to 10% of my costs. These things are the problems that make or break projects, and we can help fix them.
So now that I've placed those joints in between those windows, you can see that the program has created labels or marks for the new panels. Just because we've placed those mandatory joints where we know where we want to split up the gigantic precast wall that we had before. So after we've placed our connections and our mandatory joints, we can go to the next tab, which is just the divisions tab, which is basically a more automated way of dividing up the wall after we've placed our connections and mandatory joints. So with this, we can specify our parameters for how we want to split up this wall, whether it's based on max element length, which is specified down below, or if we want to do no division or equal element lengths, I'm going to go with maximum element length. And then we can also consider cranes and capacity rings of those cranes. For now, I'm just going to ignore those. We can specify our minimum panel length. Let's say 4 feet. And then the maximum is going to be, let's say, 10 feet. And we're going to stay 6 inches away from openings. And then we're just going to leave the division for the height of the panels to be no division. So now if I do that, select on the wall, give it a moment to think. Now the program has added even more panels and mark numbers for those panels. As you can see, it's fully gone through and panelized this giant wall for us. And the last thing to do is to add some reinforcement here. So now that we're ready to add reinforcement, we can go to the Basic Reinforcement tab. This tab has many options, but once again, once you set it up once per your standards or what your project requires, you can save it as a favorite for future use. So you can go through, specify your steel grades, the reinforcement type for both the visible and invisible faces. In this case, we're just going to use a reinforcement type that I have specified in our catalog for both the visible and invisible faces, and use the clear cover that I've specified. We can also set whether or not the reinforcement is cut around openings. We can add lattice girders. We can specify casting nuts, lifting bolts, hollow blocks, or fixtures for wall and column connections. So you can go through there, and I have it specified as I want, so I can just select on the wall. It's going to take a moment to process that. And I meant to use type 2. You can see how quickly I can make a change to the reinforcement. I didn't want to use mesh, but the type that I first specified includes mesh, so that was my bad. So I'm switching it to a type that only has reinforcement. That's what I more commonly see. I know some of our customers use mesh in their walls. So now you can see that our walls are all reinforced. Zoom in here, you can see them all reinforced now. So now that we've had all of our reinforcement and our wall panelized automatically for us, we can now start thinking about creating a shop ticket. So I'm going to pick one of these pieces, I don't know, randomly. I'm just going to pick, let's do 54. So if I want to create a shop ticket for it, just like the beam, I just have to go up to the ALLPLAN tool, select the wall, and pick from one of the templates that we have or that you've created for your layout, for your wall panels. So I'm just going to select this one. And there you go. You can see that the shop ticket was created. This shop ticket, similar to our beam shop ticket that we created earlier, it has 2 sheets, one for the forming and one for the reinforcement. It's even laying on its side to maximize the sheet space. It's dimensioned our opening for our window, called it a recess. It has the mark for the center of gravity. And it's even listed our different surfaces for the visible and hidden faces, and then the type of reinforcement, or not type of reinforcement, but concrete grade that we're using, and then also our reinforcement configurations that we're using for both the visible and invisible faces, as well as our volume and weight and mark number, and the quantity of the walls. I guess there's 2 of them. And then we also have a list of fixtures, which there is no fixtures in this panel, so there's none listed right now. So if we go to our next page, once again, we have all of our bars dimensioned out. We have our reinforcement schedule, and it's all nicely listed out for us, as well as automated. So that brings me to the end of my portion of the webinar. I'll hand it back to David, and I appreciate your time.
Thank you, David and Anders, for a great and informative presentation. We will now start the Q&A portion of our presentation. We do have a question. How does this software integrate with purchasing management or ERP systems?
I can handle that one, Nicole. It really depends quite a bit on exactly what the ERP in question is. But we have worked with customers here in North America as well as abroad to stitch the output data that can come from ALLPLAN into both some homegrown, more spreadsheet-based systems, things that people have developed themselves, as well as some of the big names out there, SAP, for instance, as well as a few others. The goal very much is to be able to leverage this data which you have earlier and are able to exert finer control over. And doing that requires it to come into the systems that you're purchasing, your operations, your financial folks deal with every day.
Perfect, thank you. It does look like that's the question we've had so far. I'll give it about 10 more seconds to see if another question does come through. Oh, one just came through. Can you export DXF or UNI files out of ALLPLAN?
Anders, if you're here, I know the answer to DXF is yes.
Yeah, I know. I agree with the DXF file type. The UNI, I'm not as familiar with, unfortunately.
I imagine they're referring to perhaps Unicam or Unitechnic files, in which case the answer is also yes, but that format's a little bit more oriented towards mechanical assemblies, so there are some limits on the data that can come through it. But the answer is yes, just with a few caveats there, if this is referring to Unitechnic or Unicam files, that is.
Wonderful, thank you. I will give it another 10 seconds just to see if we have another question come through. I'm not seeing another question come through. So on behalf of PCI, I'd like to thank David and Anders for a great presentation. If you have any further questions about today's webinar, please email marketing@pci.org. Thank you again. Have a great day and stay safe.